All right, welcome to our first flip lesson of the year. I'm not here today, obviously. I am at a meeting at a different high school, okay, but I will be back tomorrow. I'll do our homework check tomorrow, and we can talk about the weekends tomorrow as well. Okay, today we're talking about graphing on a coordinate plane, graphing using intercepts, and graphing using tables. All right, our first one we want to talk about is graphing ordered pairs. Remember that ordered pairs are always written as x comma y. All right, x comma y. All right, remember my x-axis is the horizontal and my y-axis is my vertical. Okay, so knowing that, I want you to pause this video and try the first couple. Try this page without me. All right, hopefully you actually pause the video because now here are your answers. All right, I want you to check your work, check your answers. Feel free to pause it, all right, to check your work. And I'm going to go on to the next slide. Here we go. So today we're talking about linear equations, all right, and identifying linear equations with their intercept. And we're talking about one form today, which is standard form. Okay, the standard form right here. All right. First, we talk about what makes an equation linear. Well, what makes an equation linear is the fact that x and y have a degree of 1. Basically, no squared or any other powers. All right, so I want to look for the equations here that could be possibly considered linear. Okay, x and y are separate and there's no squared term. So here x and y have a degree of 1, meaning that it's just x to the first power. Okay, with that being said, this would be a linear equation. You can also tell because x and y are not attached. Okay, x is by itself, meaning they're not being multiplied together. Here, same idea. Even though it's 2x equals 4y, this would still be considered linear. And this one, I have x times y. Immediately, that makes it not linear. All right. Here, this is just x, no y's. But if it's just x, that's okay. Like I can have that for sure. That's a linear equation. X is being squared here. This is not linear. And lastly, x is being squared again, so this is also not linear. All right. Next, it says graphing linear equations. The graph of the linear equation represents all the solutions of the equation. An x-coordinate at which the graph of the equation crosses the x-axis is our x-intercept. The y-coordinate, where the graph crosses the y-axis, is our y-intercept. So it says find the x and y-intercepts. Well, let's find x first. This graph, remember, this is our x-axis, this is our y. The graph crosses the x-axis at that point. So my x-intercept, and we write that like this, x dash int. And I would write that as an ordered pair, 3, 0. My y-intercept, my y crosses the graph, my function crosses the y-axis there. My y-intercept is 0, -2. Notice how my x-intercept, y is 0, and my y-intercept, x is 0. Okay, next, here we go. Whereas across the x-axis, x-intercept, what is that, 1, 2, 3, 4? That should be a, why did I say 3? That should be a 2. That's bad counting. Okay, the y-intercept is going to be 1, 2, 3, 4 as well. Remember, it's 0, 4. All right. Last one, x-intercept is 2 comma 0. Y intercept is 0, 4. Again, 0, 4. All right. There we go. Graph each equation by using the x and y intercepts. All right, so remember here at our x-intercept, notice the y values were always 0. In our y-intercept, our x values were always 0. So there's this method called the cover-up method. So basically to find the x-intercept, all right, so for my x-intercept, set y equal to 0. Okay, so if I set y equal to 0, I get 2x plus 0 equals negative 2. So 2x equals negative 2 because the 0 just disappears. I got this from putting this into my equation. So x is negative 1. So I go to negative 1 and make a dot. All right. For my y-intercept, I set x equal to 0. Okay, so I go to my function here. Okay, this is 0, so it's 2 times 0 plus y equals negative 2. Well, 0 times anything cancels out, and then y equals negative 2. So remember, I'd write this ordered pair as negative 1, 0, and I'd write this ordered pair as 0, negative 2. That's supposed to be in red, sorry. So I go to negative 2, holy buckets, here we go. Go to negative 2, make my line, and boom, connect my dots. There you go. Whew. Same idea of number 2, or 11, excuse me, for x-intercept. So I'm going to set y equal to 0, so it's net 3x minus 6, 0 equals 12. So 3x, you may start to notice a pattern, equals 12. Divide both sides by 3. X equals 4. So that's 4 comma 0. 1, 2, 3, 4. Next one, y-intercept. Some of us are probably may be able to do this in our head, and that's okay. I'm just showing you the work initially. So I get 3 times 0 minus 6y equals 12. This cancels out, so I get negative 6y equals 12. Divide both sides by 6, negative 6. So y equals negative 2, and that's 0, negative 2. Again, it's not always going to be that case. It just happened to happen again. All right. 0, negative 2, boom, connect our dots. And you guys don't have this, really cool tool where you can make a perfect line. Notice how my line didn't go exactly through my dots, so I just kind of make the dots a little bit bigger. It's a little trick I learned back in 8th grade. People never forget, All right. I want you to try this one on your own, so pause the video. All right, I want you to find the x and y intercepts yourself, and you're going to check your work. Here's my work for my x-intercept. Right there. Plug in 0 for y, I got x to be 5. Here's my work for my y-intercept. Plug in 0 for x, and I got y to be 3.7. It is a decimal. I'm just going to have to battle. So 3.75, 1, 2, 1, 3, about right there. You just kind of guesstimate about where it would be. 1, 2, 3, 4, 5. Graph each making a table. All right, so this is going to be a little bit different now. Okay. What we're going to want to do here, all right, I want to make an x, and that's to solve for y first if not already done so. So here, that one is solve for y. I'm going to pick some x values, and then I'll get some y values from it. I always like to go All right. Those are just random values that I like just because they're in the middle of our graph here. Just makes our life easier. So if I plug in -2 for x, so I'm going to show my work over here. Y equals 2 times -2. I get -4. If I plug in -1, 2 times -1, I get -2. If I plug in 0, I get 0. If I plug in 1, I get 2. And if I plug in 2, I get 4. All right, so I'm going to go over and graph these. 1, 2, 3, 1, 2, 3. 0, -1, -2, 0, 0. And some of us may be able to recognize, hey, I feel like we've done something with this before as far as finding slopes and things like that. That's something we're going to talk about next week. We're just going to kind of ease into it this week, not to overload you since we have a test coming up. All right, so if I look at this problem, this one's a little bit different than our last one. 14 is a little bit different than 13. The main difference, there is no x value. So if I plug in something for x and there is no x value, I'll just get 5 no matter what. So if I plug in 100 for x, since there is no x value here, y is just 5. So this is going to be a special case where I have a horizontal line. Holy buckets, that's not horizontal. Line. Okay, and that's still not going to cut it. That would look. All right, and then I put my arrows on the other end. I forgot to do arrows on this one. That's a special case. Horizontal lines are special cases. Vertical lines at some point too. All right, it said solve for y first if y is not by itself, so I'm going to subtract x from both sides to get 2y equals 4 minus x. Then I'm going to divide everything by 2. So I'll get y equals 2 minus x over 2. All right, another way this can be written as y equals -1 half x plus 2. You can write it like that too. Right, to stay consistent, I'm just going to do -2, -1, 0, 1, 2 again for my x values. And see what happens. Okay, -2, if I plug in -2 for my x, I get -1/2 times -2 plus 2. So -1/2 times -2 is going to give me a positive number. All right, that's going to give me 1 plus 2 gives me 3. If I do half of 2 is just 1. All right, so now I have -1/2 times -1 plus 2. So again, negative times negative gives me a positive. So that's just positive 1/2 plus 2, which is 2.5. 0. This goes away. I just get 2. Remember, if I plug in 0 for x, I'm actually finding my y-intercept. If I plug in 1, I'll get -1/2 times 1 plus 2, which will give me 1.5. And then I will get 1 there. Okay, so I want to graph these. Graph the ones as best you can. All right, -2, 1, 2, 3, 1, comma, 2.5, 0, 2, 1, comma, 1.5, and 3, comma, 1. Kind of do your best when you guesstimate, and then your graph should look something like that. There you go. Remember what I said, if your line doesn't cross, just make your dots a little bit bigger. All right, and that's your first ever flipped lesson. Okay, hope you enjoyed that thing. All right, the rest of the class you can work on your cumulative review packet that's due Friday for our test Friday. Don't forget about our test on Friday.